Okay, this is section 3.7 in your textbooks, page 160. We're looking at the distributive property. This is a big one. We use this all the time moving forward, so you really want to pay attention. We have a scenario here, which is a good one. However, they answer it using algebra tiles. So did a little survey before we started this video, and we're not going to use the algebra tiles. So we're going to actually move into some more kind of straightforward, applicable examples. So we'll go right into number 3 here. And we have 3a, b, c. So let's write these down. Okay, so here's 3 examples. Distributive property. It's called the distributive property because we're distributing the number or coefficient that's in front of the brackets to each of the terms or numbers or coefficients that are inside the brackets. So we can make a little arrow that illustrates that. So 4 times x is going to be 4x, and then 4 times 3 will be plus 12. Okay, so you're just distributing that first term to the next 2 terms. That's it? You good? Okay. So here we have x times 2x. Remember when we multiply variables, it's kind of like an exponent law where we see those invisible ones add. So this becomes 2x squared plus 7x. Any questions about either of those? Okay, finally the last one, 3x times x, 3x squared plus 6x. Okay, one of the areas where people tend to make their first mistake is you have something like this. Okay, that negative sign is actually a -1. Again, that 1 not being shown. But that means that -1 needs to be multiplied by the x and the 5. So that becomes -x minus 5. Gemner? Sorry. Better? Okay. So -1 times x is -x, -1 times 5 is -5. So likewise, if you had something like this, that negative sign is going to get multiplied to the 5 and to the -x squared. So that becomes -5 plus x squared. Any questions so far? All right. So we can see the distributive property here defined by this equation. A is used as any number or variable, just an example, times x plus y. So the A gets times to the x and the A also gets times to the y. Okay? So there's kind of a general example of how the distributive property works. So again, we're going to work with these examples here. We have, so example 1, this is A, 3, x plus 2, b minus 5, 4m minus 3, c Okay, first one's the same that we've already seen before, just a 3 multiplied by a binomial, so we get 3x plus 6. Second one, anybody want to give this one a shot? Neil, what do you think? Yeah?
-20m
Right?
plus 15.
Excellent, yeah. Anyone want to give this one a shot? Oh, Justin. So remember, Justin, doesn't matter the order when you multiply things.
Negative 8y plus 5.
No. So that negative 4, you multiply correctly to the 2, and then you have to multiply it by the 5.
Plus negative minus 20.
Good. So it doesn't matter whether you put the 4 at the front or the back, it's still going to multiply by both terms inside the brackets. Proper form is to always have it at the front. Okay? It looks nicer. Nicholas at the back, you want to try this one?
A squared
Yep.
subtract 14a
Good.
plus 4.
Excellent. So it doesn't matter how many terms are in the brackets, that front term will get multiplied by all of them. Okay? Any questions? All right, let's try some more. So we can see those solutions here as well. Exactly what I did in the notebook. That 4 gets multiplied backwards. The monomial is usually written before the polynomial, but sometimes it appears after. Apply the distributive property in the same way. You can also apply the distributive property to trinomials, and 4-term and 5-term and 6-term polynomials. It doesn't matter. Distributive property can be applied to polynomials with any number of terms. Okay, let's look at this second example here. X times x minus 3, you're going to multiply the x times the x, which gives us x squared. And then x times negative 3 becomes negative 3x. All right, without looking here, Gemner, what's this going to give us? P times p squared. Good. P cubed, or p to the exponent of 3. Excellent.
And then minus p squared, 2p squared.
Excellent. Yep.
And plus p, I think 1, or 1p.
Yeah, you wouldn't write the 1, but plus p. Yeah, you got it. Good. Excellent. Very good. All right, Ivan. Give this one a try. Example 3a. Sorry. Here, 3a. Ivan?
First it'll be negative 4x.
Excellent. Negative 4x. Yep.
Minus negative 12.
Not minus negative 12, just minus 12.
12.
Okay. Yep.
Plus 4. Plus 4x.
Good.
Minus 2.
Excellent. Okay, and now are we done?
No.
No, so what can we do?
You had put the same variables in random
Right? So negative 4x and positive 4x.
is 4x plus 4x is minus 12 minus 2.
Yeah, so you want to write them out? Okay. Okay.
Equals minus 14.
Good. These go away, right? Excellent. All right. B, Max. Carlos?
B, right?
Yep.
3m squared.
Good. Then what?
Minus 15m.
Right. Then what? This is where it gets a little tricky here.
And then the 3M is distributed to like the other ones too, right?
No, doesn't get distributed. The negative sign separates it. So now you're done with that. Now you're on here.
Oh, so 2m squared, so minus 2m squared.
Excellent.
And minus 2m.
Nope. Minus 1 is multiplied by this. You get negative 2m squared, and then the minus 1 is multiplied by this. What do you get?
So just m plus m.
Yes, good. Good, Carlos. Plus m. Okay, any questions there? All right. Jonathan.
Wait, sir, can you simplify even further with these are?
Sorry, yeah, you can. My bad. This would have been m squared minus 14m. Okay? Right? 3m minus 2m squared. So this becomes 1m squared. Negative 15m plus m becomes negative 14m. Okay? Jonathan, here.
So, what do you do with the half?
Yeah, just multiply 1/2 times 2. What do you get?
1/4?
No. When you multiply a fraction times a whole number, you can put the whole number over 1, right? So then you multiply your numerators and your denominators. So this would be 2 over 2, which is 1, right? Or you can just think of it as a half of 2, okay, which some of you might know already is just 1, okay? So 1/2 times 2w gives us? Right. Very good. 1/2 times negative 6. Six? No, what's a half of 6?
Oh, 3?
Right. And is it positive or negative?
Negative?
Good. Negative 3. Excellent. Now, minus, because it's a negative times a positive, 2/3 of 9.
That's 9 over 1.
Yes, good. So if you can do it like this. Yes, 18 over 3, which is 18 divided by 3?
5?
No. 6. Good. Close. Okay, so this is then what? Negative?
6W?
Good. And finally, 2/3. Negative 2/3 times negative 6.
12 over 3?
Right? 12 over 3, which is? 12 divided by 3, 4. Yes. So then negative times a negative is?
Plus?
Yes, plus 4. Good. Okay, and then finish it off, Jonathan. W minus 6W. 1 minus 6.
Oh, it's
No. If you have 1 and you take away 6, what are you left with? Yeah, negative 5, right? Negative 5W. You can use your calculator too for this if you need to, right? It's no problem. And then, so negative 3 plus 4?
1?
Yeah, good. Make sense? Any questions? All right, let's check our answers here. We have negative 5w plus 1, m squared minus 14m, which is there, and then minus 14. Good. Okay, we got one more example here. And it's under nested brackets. So this is example 4. 3, 2 plus 5, 2k minus 1. All right. So when we're working with brackets and we have two sets of brackets, where do we want to work first? Am I going to start doing this right away? What do you think, Vincent?
I was gonna like say that you would take the 5
Mm-hmm.
the inside of the brackets and distribute it to the brackets inside the brackets.
Yeah, so you're gonna work on the inside brackets first, okay? Always, 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 okay? So here's 3. We'll leave that alone. Plus now, Vincent,
10k,
good,
negative 5,
good. Very good. Okay, next, Vincent.
6,
So, hold on. We gotta simplify in here first.
oh yeah. So negative 3 plus 10k.
Good. Okay, you could have done the 6 and then multiplied that, but it's more work, okay? So now we just have to distribute the 3 to 2. Okay, go ahead.
So negative 9
Yep,
and 30k.
excellent, plus 30. And then I would it's good practice to write the variable term first before the constant. The constant always goes at the end. Any questions about that? Scott, you're good?
How did you get negative 3?
Negative 3?
Yeah.
I added the 2 and the negative 5. Okay? All right, key concepts are here. The distributive property allows you to expand algebraic expressions. A times x plus y is equal to ax plus ay. When distributing, multiply the monomial by each term in the polynomial. Multiply numerical coefficients. Apply exponent laws to variables. Pretty simple. Okay? This will come hopefully pretty quickly with just a lot of practice. Okay? Any questions for the lesson? All right.